Hello, grade 3 and grade 4. We are finally moving on to the last topic of the week for math, and our last topic of the week is going to be on reflections. And when you think about reflection, you can think about a mirror, just like when you stand in front of the mirror in your washroom or in your bedroom. When you look into the mirror, you're seeing a reflection right back looking at you. So we're going to think about reflections or flipping over an object, because a reflection in the mirror is just the flipped version of yourself. So we are going to flip figures over a line. We've already talked about the line of symmetry this year. You can think of it the same way. We are going to flip a figure over a line so that we draw the exact same figure again, and the figure will be symmetrical. It'll be the exact same size, the exact same shape. The only difference is when you flip something from one way to the other, it's now going to be facing the opposite way. What used to be on the left will now be on the right. If you flip it from top to bottom, what used to be on the bottom will now be on the top. And what used to be on the top, where my fingers were, will now be on the bottom if I flip it from top to bottom. So we can flip these left to right, which would be flipping them horizontally. We can flip them top to bottom, which would be vertically. We can even flip them diagonally. We don't do many flips diagonally in grade 3 and grade 4. Those are for the higher grades. We mainly stick to horizontal flips and vertical flips. So if we turn and we look in the textbook, a really good example of this is when we look at the grade 3 textbook. We can see here they call flipping a reflection. And if we look at this letter F, the letter F here was flipped over, so now it's backwards over this black line on the grid. We call the line that it flips over the reflection line. What I want you to really key in on here is that the letter F, even after it's flipped, is still the exact same size, it's the exact same shape. The only difference is the side here of the F that used to be on the left, well, over here is now on the right. And the sticks that point out on the F that used to be on the right, after it was flipped, now they're over on the left. If we look at over here on this one on the right, our line that we flipped over, our reflection line, was a horizontal. It went horizontal. So we're flipping it from top to bottom or bottom to top. That's called a vertical flip. And what you would notice is this was a rhombus. All four sides are the same length, but they're on diagonals. But you can see that the rhombus is the same size, the same shape. The corner that was up in the top, the vertice in the top is now at the bottom. The vertice that was really close to the flip line is still really close to the flip line. This vertice touched, it's still touching. It's just been flipped over. The vertice that was farthest away is still farthest away. Same as on our F. The vertice on the farthest away of the F is still, after being flipped, farthest away. So when we want to look at a grid and we want to flip our own, what will normally happen is we're going to be given a figure on grid paper and we're going to be given a flip line, and we have to flip the figure over on the grid, on the line, on the flip line, onto the grid, and we have to draw its image. We could be asked to flip it horizontally, left to right, or right to left, and we could ask to be flipped it vertically, up to down, or if we were given one on the bottom, we could down to up. The easiest way I can show you to do it, and that I try to teach my students year after year, is to mark your vertices with dots, and then if you're going to be flipping it left and right, you start at your flip line and you count across to your dots. So if I start at my flip line, I can count 1 and 2, 3 intersections to the left. So I go back to my flip line, 1, 2, 3 intersections to the right. From here, I am 1 to the left, so I would be 1 to the right. Start at my line again, 1 to the left, so I'm going to go 1 to the right. This top one is Start at the line, 1 to the left, 2 to the left, 3 to the left. So 1 to the right, 2 to the right, 3 to the right. And then when I'm done, I can connect all 4 of my new vertices together, and I will see that they are flipped over. My far outside is still on the outside, but on the opposite side. My bottom is still on the bottom. It's the same if I'm flipping a figure from the top to the bottom. Go to my flip line. I'm going to count up 1. So now I'm going to go back to my flip line, count down 1. My flip line, up 1. So go to my flip line, down 1. I'm going to do my top left one now so that I go to my flip line. It was 1 up, 2 up, 3 up, 4 up. So go back to my flip line, 1 up, 1 down, 2 down, 3 down, 4 down. I've got another vertice here, so it's on this line. So I'll count 1 up, 2 up, 3 up, 4 up. I'll go back to my line, 1 down, 2 down, 3 down, 4 down. And the only other vertice I have is 1 up, 2 up, 3 up. So I'll count 1 down, 2 down, 3 down. And after I've drawn all my vertices, I know I have 5 vertices. I make sure I've got 5 vertices drawn. I'll connect the dots in order. And what I have is a perfect image drawn. And I've got my figure flipped. What used to be on the top is now on the bottom. What used to be on the bottom is now on the top. The left side is still my left side, my right side is still the right side because I was just flipping it top to bottom. So that's the work that you're going to be doing for me today. You're going to be working on, with grids, flipping figures either left and right or up and down, horizontally left and right or vertically up and down. And that's going to be the activity we're going to work on today, working on flips, also known as reflections. Let me know if you have any trouble with it, but the easiest way is to start at the flip line and count up or down or left and right until you get to your vertice, and then do the exact opposite in the counting in the opposite direction. Good luck.